Good afternoon. My name is Karl Weaver. I am going to invite you to my webinar, which is called the AI Chip Supply Chain in Asia and Generative AI Smartphone Revolution. I hope you enjoy this. Okay. Again, my name is Karl Weaver. I'm a wireless market mobile device specialist for the Far East. I've spent my entire professional career bringing cutting-edge mobile technologies into Asia in the wireless, the mobile, the smart card, the semiconductor ecosystem. This evening's presentation is called the AI Chip Supply Chain in Asia-Pacific and the Gen AI Smartphone Revolution. I'm combining these two topics. And really, what is artificial intelligence? Well, it works by simultaneously simulating human intelligence through the use of algorithms, data, and computational power. The goal is to enable machines or software to perform tasks that typically require human intelligence, such as learning, reasoning, problem solving. And so that's what AI attempts to do, which is to mimic the human brain. Let me continue further. Okay, so it is actually a third revolution, which means super intelligent AI solutions in every application, AI tools, both hardware and software. But let me go back to my professional career. So I started to learn Mandarin Chinese in Taiwan in 1982 up until 1985. I spent 3 years on a scholarship from the Taiwanese Ministry of Education at National Taiwan Normal University Mandarin Training Center to study Mandarin Chinese. In 1985, I jumped into the microcomputer manufacturing industry with a company called Digicom, and I rode that up until 1992. So as you can see here, the PC era, 85 to 95. I actually returned to the United States and I settled in the Seattle area in late 1992 and 1993. I joined the land mobile radio communications industry. Around the turn of the century, I jumped into the digital cellular industry and the smartphone ecosystem, SIM cards, et cetera, et cetera, et cetera. I rode that wave up to the present. I've been in this ecosystem for since the 90s, about 30 plus years. And now I see the need to understand and evangelize to executives the AI era. It's very, very important. And basically, it involves using artificial intelligence and then machine learning and then deep learning, which is neural networks, in order to come up with the generative AI usages on smartphones and IoT devices from cloud and data center servers that are powering all these applications. Let me move further. Let me move forward. So global enterprise AI talent. It's actually all over the world and it's growing rapidly. And so United States really leads in the AI algorithm side of that. But if you look at this top 10 country chart, United States is leading in that, but China is just really not very far behind, or maybe even in parallel, really it's about equal now with the United States. A lot of people don't agree with that. I think it is. Japan, Germany, United Kingdom, India, France, South Korea, Canada, and Australia. But if you see here, much of the talent comes from outside the country, and then when they come to the United States, these big companies actually they bring the talent in and they help to develop the AI talent in the United States. Let me move forward. The global ecosystem for AI chip development, Taiwan leads in that. Taiwan is 90% of all the AI chips in the world are produced in Taiwan. The AI actually leads in the US actually leads in the AI algorithm and also the GPU innovation with, of course, NVIDIA. China actually leads in the manufacture of the data center server technology for cloud computing. The companies like Dell, HP, IBM, they actually have the names on the servers, but the servers are actually made mostly in China. And then, of course, the rest of the Asia for components and material supplies. This is very reminiscent of the entire semiconductor ecosystem supply chain. Let me move forward. Semiconductor ecosystem is incredibly complex. Leading semiconductor companies, NVIDIA is leading right now. NVIDIA doesn't manufacture semiconductor chips, but they design their GPUs, and the GPUs are going into every single AI data center, AI-enabled data center to generate AI applications on the planet. And one of these GPUs, the H100 from NVIDIA, one of these AI GPUs cost upwards of $25,000 to $30,000 per. And Elon Musk, for his Tesla vehicles, it has a few thousand of them in his data centers. Anyway, TSMC is the actual manufacturer of these chips. They manufacture upwards of 90% of all these chips. The industry is actually it's fragmented into two types of companies. One of them is IDMs, which are vertically integrated chip design fabrication houses. Intel and Samsung are those. They actually make everything from start to finish. But you also have lots of fabless firms. For example, Qualcomm, Broadcom, and even NVIDIA, they're fabless. They contract the manufacturing out to TSMC. HiSilicon, which is the in-design house for Huawei smartphones and Huawei product, they still use TSMC to manufacture the AI side of the chips, although they're also working with SMIC, which is a semiconductor manufacturer inside China. And as you can see, the forecast for edge computing is quite high. And wearables, speakers, tablets, and smartphones, you can see here that the estimates are quite large. Now, this chart or this diagram kind of gives you an idea of the global impact of not only semiconductor chips, but also the AI chip supply chain. It's very complex. Not any one company or country can control, can dominate or monopolize, although TSMC right now does make pretty much 90+% of all the AI chips in the world. But the AI chips go into servers. Those servers go into data centers. Data centers are used to create cloud computing. And so you have a complex ecosystem. The United States is involved. China is heavily involved. Taiwan is involved. UK is involved. Even Israel is involved. A lot of companies. So this is the impact for generative AI. Memory, advanced packing, and substrates, along with these processors, it's a very, very broad spectrum of players. Let me move forward. Taiwan, again, as I said, is the hub of semiconductor manufacturing. Hsinchu, for TSMC's manufacturing, that's the home. They're the largest semiconductor foundry. Foundry is the manufacturing facility, the fab, we call it, in the world. They're also leading in 5 to 3 nanometer chips, and they have strategic partnerships with NX, NVIDIA, AMD, and Apple, actually many, many companies. Let me move forward. The United States is really the key for the algorithms. We have so many companies from Meta to Microsoft to Amazon to Google. Those companies are designing and bringing in talent from all over the world to design AI algorithms. But then there's NVIDIA, which is based in California and has a very strong presence in Taiwan, obviously. The founder is originally coming from Taiwan. You'll find many semiconductor people from Taiwan globally bringing this technology because Taiwan is the center for this semiconductor manufacturing expertise, quite honestly. Anyway, back to the United States. We're leaders. We have the leadership in AI algorithms, AI algorithm development. OpenAI is producing ChatGPT, Google, and many, many others. NVIDIA's role in designing the cutting-edge GPUs for the AI processing. The GPUs need to process the AI chips in the data centers. And there's a collaboration with TSMC for advanced chip fabrication. China is the backbone of cloud and server and OEM manufacturing. They make all the data center servers. They make most of the servers. When you think of going into the cloud, you're actually really you're using edge device up into the cloud services, which are costly, and those are cloud services. The cloud services actually are in data centers and data farms. So China dominates in cloud and data center servers. They dominate Alibaba Cloud, Huawei Cloud, and even Tencent. Key players are supporting the infrastructure for AI development, and China is rapidly developing AI and robotics for AI. There are geopolitical challenges impacting the supply chain. This presentation is not about hype or hysteria. I will avoid discussing too much about geopolitical issues. Now, cloud computing is based on massive data centers powered by sprawling server farms. So as you can see, this slide shows server farms. And basically, servers are key demand drivers for AI chips because most training of these AI algorithms actually occurs in these cloud data centers, these data farms. And actually, China's Huawei has forecast that by 2025, 97% of companies will be using cloud AI. They absolutely will. Hardware and software. Elon Musk is building a large data center in Tennessee right now. This is a slide shows the AI chip landscape from cloud providers and data centers. So you have to equate cloud providers and data centers are not exactly completely the same. And many of the cloud providers actually emulate because they also have the data centers. So this slide actually kind of explains that. And that's because the use of generative AI needs public cloud services. Let me move further. Let me go on. Cloud AI and AI at the edge smartphones. So AI occurs in the cloud and data centers and pushed down to edge devices. In this case, mostly Internet of Things devices. It can also be pushed down to a smartphone, but there's a problem because of legacy and latency. Because of latency of the smartphone. So it's much better for the smartphone itself to be able to generate in the mobile apps processor chip the GPU instructions needed in order to power the AI, the generative AI that's needed on a smartphone. And so you see two types of AI at the edge and in the cloud. And there are different types of AI chips. You've got graphic processor units, that's so-called GPUs, field programmable gate arrays, application-specific integrated circuits, and tensor processing units. These are all components of the typical AI chips. There are actually other important components of the AI chip, but basically when you come back to the cloud AI, the computation takes place in a server. The results are sent back slowly. The time is slow. So slow response times. So more privacy concerns, and also data needs to travel vast distances. So when you're sending it down to edge devices like an IoT device, like a Tesla vehicle, it's going to be slower. That's the problem. So more battery consumption, but more powerful. It is more powerful, but it doesn't need connectivity. So you can see here, the cloud and data centers, as you can see from this chart here, the cloud and data centers, they bring real-time data processing, data caching, buffing, optimization, and also machine to machine. That's where one machine can send data to another machine, also using the cloud. And as you can see here, storage batteries, smart metering, connected smart cars, more Internet of Things like green energy, solar panels, wind turbines, and power generation. Those are actually all AI can power all of that technology. But on the smartphone side, as you can see, for the AI chip on a smartphone, you've got memory, you've got MPU and GPU and CPU. CPU in this case we call a mobile apps processor chip. Let me move further. Let me move on. So cloud companies, they actually design AI clouds solutions for data center servers. Amazon, AMD, Google, Intel, Microsoft, NVIDIA. Cloud companies are designing these custom chips for their servers because they need need to run the CPU cores in parallel, which is very, very important, making AI run faster and better. And NVIDIA, as you can see here, this NVIDIA H100, this is the most highly sought after piece of AI chip hardware on the planet. And it's not, and not everybody can afford it. Not every company can afford it, but lots of companies want it. Training AI chips. An AI model is fed millions of examples of the subject matter that it's trying to learn. And they do that through large language models. The better the large language model, the more data can be fed. So good data in, good data out. Garbage in, garbage out. And then there's also the importance of inference. The inference allows the AI chip used in training to generate the content. Inference costs inference cost is actually critical to the value of the training models. So it's very, very important that you inference equals the amount of data and results, positive, effective data and results that you want to get out of the creation. So the creation of the data. So the integrated supply chain across Asia-Pacific, you've got South Korea for memory, Samsung, SK Hynix. Japan supplies the photoresists and the silicon wafers, and there's a collaboration for resistant supply chains of other types of components need. This is not a one-off kind of company that can manufacture everything. It's just not possible. There are geopolitical tensions, supply chain risks, and there are better opportunities and there are opportunities to strengthen partnerships and regional diversification. For example, TSMC has decided to put a fab in Phoenix, Arizona, also in Japan, also in Germany. But it is about balancing competition and collaboration. So TSMC actually sells to China, but China has its own SMIC to manufacture its own chips. However, TSMC still has a factory in China, and TSMC needs to diversify to grow this technology. Let me move forward. What is the future of AI chip supply chains? Taiwan's critical for the manufacturing of the AI chips. U.S. is critical for the AI innovation in terms of the AI algorithms. China is important for the server technology for AI, where the AI actually generates and takes place all over the world. And there's a call to action to really strengthen these partnerships to foster innovation amongst the entire ecosystem. There's an environmental cost, though. If you look here, the CO2 emissions from a data center are the most in the world, and that's what's causing much of the CO2 carbon emissions in the world. It's not an airplane, it's not your vehicle, it's actually data centers. That's the dirty little secret of this ecosystem. And if you think about it, just one ChatGPT query could consume between 50 to 90% times more electricity than a simple Google search. So as you can see, more energy intensive, it's more energy intensive, and it leaves a big carbon footprint. That's very, very key to understand. Let me move forward. And AI's call of reckoning is this looming climate cost. There is a looming climate cost. These energy demands, though, they are amid these data center races. So everybody wants to produce data centers and cloud services around the world for AI, but they don't have enough energy to do that to maximize the value of AI. And the electricity demand in Asia Pacific is going through the roof. Some people say they will try to produce nuclear power plants right next to these AI data centers. That will or will not be a solution. Will be interesting to see in the future. Now, let's talk about the growth of Gen AI on smartphones. Basically, AI has been on smartphones for quite some time. These are the top Gen AI-enabled smartphones. Samsung's got a few, Google, Apple. The Apple Pro 16 and actually Apple Pro 15, the 16 Pro and actually the 15 Pro, Apple has just released its generative AI Apple Intelligence OS to accommodate these. Huawei Mate 70, Honor, Magic, and Xiaomi, they all have generative AI smartphones. The generative AI chatbots and market share. So actually, what is ChatGPT? It's a Gen AI chatbot. Perplexity, ChatGPT, Gemini, which is from Google, Anthropic, Claude AI, and Copilot, which is from Microsoft. The most popular generative AI tools is ChatGPT. Gemini is also coming in second here. And so it's really important to note, what is AI? It's basically computer systems and software that are developed to allow machines to perform tasks instead of humans. And machine learning, they're using algorithms to allow the computers to learn instructions. And that's why they need the large language models. And of course, an AI system that generates text, images, and media, audio, video, and allows for a response to a prompt. You prompt the Gen AI to do something, and it will create something for you. Natural language processing, this is where computer science meets linguistics to allow computers to understand and process human language. And again, ChatGPT comes from OpenAI. It uses generative AI, natural language processing. Apple versus Huawei. Apple has just come out with Apple Intelligence, and you can find this. The most value you get is on the latest version of the iPhone 16 Pro. And it's key to note that. Now, Huawei also has manufactured by SMIC. Huawei also has its own AI chip. And so the race is on between these companies and more. Gen AI smartphones, they're exploding on the market. And you can see Apple, again, as I said, has come out with Apple's new personal intelligence system, which can help you to write and express yourself and get many things done, at least, well, that's what Siri told me. No, and I'm not kidding around here, but actually Siri was a simple way to use AI to ask simple questions. What's the weather today? Now, with Apple's new personal intelligence, Apple Intelligence, it will be Siri on steroids, essentially. And as you can see here, by 2027, there are going to be 520 million generative AI smartphones in the world today. So this is an important market to watch and follow. And by the way, it's probably on your smartphone right now, and you don't even know it, and you haven't begun to use it. I suggest you start using it. So if you think about it, the evolution of Gen AI on these smartphones, it begins with simple tasks like predictive text, asking Siri, but it'll migrate to asking more complex questions. And since it's at the edge in your hand, the smartphone is at the edge and in your hand as you're asking questions, you'll be able to actually gain more productivity by using it. It supports real-time image recognition, augmented reality. It's going to be powered by these AI chips, neural engines, and robust software ecosystems like TensorFlow Lite. This is fueling machine learning for the AI system. So it's all here now. I just want to let you know it's here. It's not hype, and it's also certainly not hysteria. Some of the applications driving Gen AI growth, camera and imaging. Basically, you'll be able to do all kinds of photography kinds of things you never expected you'd be able to do. Personal assistance, more like an AI agent. Well, Siri, Google Assistant, real-time translation, that is all coming. And it's going to get more sophisticated with AI agents in 2025. Security, facial recognition, fingerprint detection. These all help to support the edge device that you're trying to protect from hackers trying to infiltrate your data. User personalization. Your smartphone, your IoT device, your smartphone will give you suggestions down the road. Hey, it's time to have your coffee. You seem to be running out of energy. Or maybe you should go and grab a donut. It also will help the power management of batteries. It'll do many things. And augmented reality, as I said, will be accelerated with AI, because AI will be able to create all kinds of interesting new plots and imagery based on your own requirements that you send prompts into. And there'll also be all kinds of enhanced gaming, online gaming. Key drivers of growth, of Gen AI growth: edge computing, absolutely, on smartphones and IoT devices; user demand, expectation from intelligent predictive features; AI agents, the ability for your smartphone to program your entire day and let you know and prompt you when you have things to do; affordable AI chips, that's coming down the pipeline. In the future, there'll be no feature phones. It'll all be a smartphone, no matter where it is going in the world, because the prices are continuing to go down, especially for the mobile apps processor chip for these AI systems. Let me continue. these are some of the challenges for Gen AI on smartphones, and I focus I focus on iPhones in this particular scenario here, giving you an idea of the CPU, the GPU, and the RAM requirements. And let me move further. The future of Gen AI on smartphones, real-time AI. I mean, it's there right now, and using enhanced augmented reality and accessibility tools to actually drive the factories of the future with robotics. Think about that. But also, it'll be hyper-personalized, personalization of tailored user experience. You can program it to do so many things, not just set the alarm in the morning to wake up. It will be able to do so many other AR kind of duties for you. Health monitoring, absolutely. As long as you hold the smartphone in your hand, it'll be able to determine your actual physical health and give you health suggestions. You need protein, you need vitamins, et cetera, et cetera. And AI-driven innovation. This is all happening. Augmented reality, foldable smartphones, although in my humble opinion, a mechanical foldable smartphone is actually, I don't trust them to last very long, quite honestly. That is my PowerPoint presentation. My name is Karl Weaver. My Chinese name is Wei Kar. Newport Technologies is my public speaking entity to evangelize cutting edge mobile technologies in the Asia Pacific. Thank you so much. I appreciate your time.